Hello, so we're back, and this time we have a nice laptop to repair. This is a HP i7 Elitebook A40G8. Yeah, it's an interesting story with this laptop. Let's check the customer email. So what the customer is saying, it will not charge via both USB-C ports. He contacted the HP support and they quote the repair for £500 plus. I mean, quite expensive. The machine is out of warranty. He checked for damage and liquid damage, and is no liquid damage. Connecting the USB charger without the battery connected, testers show only 5 volts. So without 12 volts battery, the PD controller appears to be inactive. So this is a skilled customer. Yeah? To know about a PD controller, you have to be skilled. He googled the issue, and the model seems to have a history with USB-C port BIOS firmware related issue. And he supplied this laptop with another motherboard, partial shorted CPU, which does start up to a point and work with USB-C. So he sent a motherboard for spares, same motherboard with a CPU issue. So we do have spares. So if we have spares, can we fix this laptop? That's my question. I mean, we have everything. I mean, lol, check here. So you have 1 BIOS chip, 2, 3. Yeah, 3 BIOS chips, right? Yeah. Okay, let's leave this on one side. Let's try to understand what is the problem. I mean, just because, you're telling me it's not charging and you are going on a rabbit hole. It's about, just following the path for a repair, I cannot go away from that path because I'm going on the same rabbit hole, same way like the customer. So we have to follow our path. Let's open the laptop and let's have a look inside. So I understand the laptop is working on the battery, but it's not charging. What is interesting, and this is making me confused, the customer is saying on the USB-C showing 20 volts, then he's saying shows only 5 volts. So maybe when the battery is charged, it's showing 20 volts, and when the battery is not connected, it's showing 5 volts, and that's quite simple. I mean, just to understand, I mean, from my point of view, you check here, my point of view before checking. Yeah, before checking. I haven't checked the laptop. So with the battery, yeah, it's showing 20 volts. Without the battery, showing 5 volts. Means, yeah, because the PD controller has to speak with the EC chip. So you have 20 volts with the battery connected because the EC chip is live, yeah. But if you don't have battery, showing 5 volts, that means the EC chip is off. That means it doesn't have power. That means even if you have 20 with the battery connected, that means that 20 don't reach the main power rail, don't reach the LDO power supply to supply power to the EC chip. So yeah. So the EC chip is alive and has power only when the battery is connected from the battery. This is quite like a fault like Lenovo. You remember Lenovo who is falling mouses from the board? Same story. You have 19 volts on the USB-C on the meter, but the 90 volts are not reaching the main power rail. So basically the customer is telling us actually the fault. Yeah. Good. So the battery is connected. Let's plug a charger. Let's see what it's doing. So the solution was actually on the email. Wait a second. We have USB-C. Well, 1 second. We have a round charging port. I mean, why I will use the USB-C? No. Let's use the round one because with the round port, you can diagnose a laptop more easy. So, 19 volts. It's a lot more easier with the normal round port. Plug in the charger. And the laptop is taking some power. Check there. 300, 500, 7, 9. Now we have the red light here. 1 second. So this laptop is working on the round pin. So basically the laptop is working, but the only problem, it will not charge via USB ports. Okay, that's strange. So the laptop, it is working and it is charging, but not via USB-C. Pressing the power button, the laptop is coming on. It's taking like 3 amps and we have picture. Okay. That's okay, that's fine. So plug in the USB-C. Where? Oh, here. Yeah, here we have USB-C ports. And the meter, it is coming on. Check there, 20 volts. I told you the customer tell us the fault from the email. So we have 20 volts, that means the PD controller is working, the PD controller is speaking with the AC chip, yeah? So why is not charging? Because the 20 volts is not reaching the main power rail. You see the main power rail? Check here, MOSFETs, capacitor. No, actually here, capacitor. So the main power rail, I mean, clearly the main power rail is the one provided by the battery, right? Main power rail 0 here. No, actually 0.5. Why the main power is not present from the battery then? Because this is not the main power rail. I can't work with the laptop like that. I have to have the board like that and the battery there. So now, yeah, now it's a different picture. So here you have 0, here you have, check on the screen, 12.2. So the main power rail is only the one provided by the battery. Okay, so we have a board. We have, this is the Thunderbolt ICs. Where is the PD controller then? This is the EC chip. You know what? I have no idea where is the PD controller. I mean, I can see the MOSFETs here, you can see. So clearly the MOSFETs probably are from the USBs. Yeah? So they are coming probably from the USB-C. But where is the PD controller chip? We don't know. Let's analyze the board under the microscope. The customer said this board actually is showing 20 volts. Yeah, we check here. So this one is showing like 19 volts without the battery. But if I disconnect the battery on this one, it's showing only 5 volts. Good. Let's check this board under the microscope. Yeah. Let me leave the laptop on one side. So we can see the high-speed data Thunderbolt Intel chips, which are here. I mean, not sure what chip is this. Can be like a PD controller. We have here, most likely the PD controller firmware. I mean, can be also some BIOS from this CC chip. Check here. You know what is this? You have to admit it. You are on this channel for a while, yeah? You know this chip is a prick. You know this chip has a fault from the factory, yeah? Always there is a problem with this chip. And it's not a problem. I mean, the chip is not burned, speaking with AC chip. The chip is burned by managing the MOSFETs. These MOSFETs, yeah? You know that, right? Yeah. Okay, so the MOSFETs are exactly under the M2 drive. Good. Let me take out the M2 drive. Let me disconnect the battery because I'm not sure if the laptop is off or it's on sleep. So the M2 drive is out. Plug in the charger. The battery is disconnected, you can see. We have 5 volts with the battery disconnected. Yeah, I know. I mean, even if we are connecting the... Yeah, we can connect the battery. I think it's more easy. Just to follow the 19. Yeah, now we have 19, right? Yeah, 20 volts. Let's go under the microscope. I mean, it's even point trying to do anything. Check here. Check here. This one is burn. This one is burn. I mean, you can see how the solder came out from the... Yeah. This is a classic fault of that chip. Okay, let me go on the voltage. So check here. The input voltage here is... Just tell me the voltage. 20 volts. You can't see. Sorry. The input voltage is... Check on the screen. 20 volts. The output voltage from this MOSFET is... Check on the screen. 2 volts. 1 volt. Yeah. Why? Because the MOSFET is burned, obviously. But also because on the gate we have 18. Yeah? We should have 25. Yeah, it's not 25 there. No. No, it's not. Here we have... No, okay. It's not connected. Let me swap the charger. So swapping the charger here. And here we have 20. And at the output we have 1 volt. Yeah. Yeah. And now you'll ask, sorry, but how can we check your theory? I mean, you're an old guy. You are sure about what you are saying? Huh? Let's short the MOSFET. So shorting the MOSFET. And the meter is switching off and on. Check that. Check the current. I want to see the current. 1 amp. And it's charging fine. 1.4 amps. You can see? No, it's not the MOSFET. I mean, the MOSFET, it is burned. But even if I replace the MOSFET, it will get so hot, they will die again. Because the issue is the gate voltage. The chip, it's well known to have a fault with the voltage boost pump, which is supposed to supply 25 volts to the gate of the MOSFET. So if you're supplying only 19, then the voltage, the current is passing the MOSFET through the diode, has an internal diode. So the MOSFET is off because you have no voltage on the gate. And the voltage it will pass, the current it will pass the MOSFET through the internal diode. And obviously it will get hot. And it will get burned at some point. The solution is not really a solution on this case. No, even if you replace that chip, it will die again. Because it's a design fault. So I'm not sure what should I do. Let me speak with the customer. Yeah, because shorting the MOSFETs, it's a better solution. The problem is, if you short one MOSFET, everything is fine, it's working great, but it will charge only from one port. If you short both MOSFETs, it will charge on the both ports. But if you have plug a charger and you have plug a USB, external hard drive, the 19 volts or 20 volts, it will comes out to this port. And that's, it's not something you're looking for. Let me try to give customer options, yeah? And here's the option, I can't give warranty. I can't replace that chip and give warranty. So it's up to the customer. We are moving the risk on the customer side. So let me ask the customer, and I will come back with a solution, yeah? See you soon. That sucks. The customer wanted like original. So I explained the customer, but like I said, the customer is a skilled guy. Anyway, he said he wanted like the original, replace the PD controller and MOSFETs. Of course, I gave him to choose from, it's a gentleman called Mark. I explained him, Replacing the chip can die, you know, I cannot take that risk. But the customer choose to keep the risk on his side. So we have to replace the chip and the and the MOSFETs. So I will say, just give me some time. Yeah, we have work to do here. We have to take the board out and all the stuff. Yeah, I know. I know that sucks because we can fix it today, and tomorrow can be dead. That's the thing. The chip has a design issue. Yeah, but still, there is a chance for us to achieve a dodgy repair. Maybe the chip has like a different termination. Like you have the number, then you have a letter or two letters. Has to be exactly the same. If are not the same, it will not work. So yeah, it's not over yet. And the motherboard, it's out. Yeah, let's check the PD controller. So the PD controller is ending in AD. Yeah, you see the AD? The AD matter. Now let's see on the spare board from the customer. Let's see it. And the spare board, it's AD. I can't believe. That's freaking insane. It's exactly the same chip. I can't believe. We have to replace it. Oh, what a lucky customer. Okay, let's do it. Unbelievable. So we have the old chip here. I'm gonna use some rosin flux. Actually, you know what? Let me get that chip hot. I mean, we have one shot to replace that chip. You know what I mean? So we have to be sure everything is going as planned. Good. The alcohol is getting evaporated, so gonna have some dense flux under the chip, and that's important because we are replacing the chip with no rebolting, right? The flux is boiling, which is good. And now we can remove the chip. Perfect. Check there. Perfect solder balls. What do you think about that? Huh? Good. So that's the old chip, which is burnt. Okay, and this is the customer spare board, which is working, yeah? So we tested and the PD controller, it is working. TPS 65994. Yeah, pretty crappy PD controller. Good. I'm using 480 degrees. No way. No way. Where is my chip? Where is my chip? Found it. Ah, lol. Found it. It's here. That's crazy. Okay, let's check the chip. And the chip solder balls. Looks bad. Yeah. We have to take the solder balls out. Luckily, we have the from the where we took the chip out, we have the solder balls there. It's fine, you know. Even without the solder balls, we are still fine. No problems. Good. So we have a chip with no solder balls. And that's fine. So the chip position is with pin number 1 there. Yeah. Solder balls on the board are exactly perfect. Let's solder the chip. 480 degrees. Let's hold the chip on the middle. That's crazy. You know, I'm trying to not press with the tweezer because we can crack the chip actually. And I don't want to crack the chip because I don't have another. And even this one is not mine, so I'm trying to be very careful. Good. And the chip, it is soldered on place. Huh? What do you think about that? Straight, right? Yeah, it is straight. Now we have to deal with the MOSFETs, and here is a problem. The MOSFETs are welded, probably. Actually, one MOSFET. This one, most likely it's welded. But I'm gonna try to take it out. You see? That's a solder ball. No, the MOSFET is dead, clearly. Actually, it's looking quite good. Yeah, check that. So we have one MOSFET, and we have the second MOSFET here. Yeah, it's looking fine, right? Let's use some 180 degree solder wire and some rosin. Looking perfect. I mean, it's too much solder, but it's fine. And here. Perfect. Good. We have somehow to take the solder out. Nah, I don't have weak wire. I mean, I lost it somewhere. But we do have a coax cable. Huh? You can take some old TV cable and use it like a weak wire. Yeah? Yeah, and the solder it's out. Good. Perfect. So the MOSFET it is soldered. Now let me grab the other MOSFET, which is here. Good. Perfect. So the MOSFET it is soldered. Okay, let me clean the board. Perfect, like brand new. Let's test it. So plug in the charger. Yeah, it's fine. We have light here. Check here. 20 volts with no battery. Huh? And here, 20 volts with no battery. The voltage on the gate, Yeah, the fan is spinning. It was spinning. The voltage on the gate, 28 volts. Check there, 28 volts. What do you think about that? Yeah, I know I let you down. I know that. Yeah. Sorry guys, no dodgy repair on this video. But I'm gonna try. I'm gonna try to catch up on the next video. Huh? What do you think about that? Yeah, I'm pretty sure we can do it. No, be honest with me, yeah? Be honest. Be honest to yourself. It's not boring. Really. It is. When actually you do nothing to correct the manufacturer mistake. Obviously, when they build the laptop, they didn't know actually the chip has an issue. So basically, we are, continuing the manufacturer, the design error. Of course, it's not their fault, but I said that many times before. My own laptop, all short, every MOSFET, the MOSFET from the input, just because I lose no current if I share MOSFETs, right? There is no current. If it's no current, that means it's no heat. Yeah, that means not only the laptop is more efficient, power efficient, but I have no liability on the board. I mean, my MOSFETs cannot die if there are no MOSFETs, right? Yeah, no MOSFET, no shorted MOSFETs. So the MOSFETs are good. Definitely, they are good when everything is working fine. Yeah, not when you have a problem with the driver of the MOSFETs. Of course, if the customer is looking to sell the laptop, he wanted like original. So I understand, his decision. You know what I think? I think the people are too nice. They try to be like the gentlemen. Said they will not tell me, sorry, I don't want a dodgy repair. But instead, they're sending me a spare motherboard. So on that way, they know I have any part I need for the repair. That's what I think. Yeah, that's what I think. It's not the first customer which is sending me like a motherboard for spares to repair his laptop. Anyway, all back in place. Plug in the charger, plug in the battery actually. Battery is plugged in. Let's see the charging current. And we have current. Yeah, we have current. We have 900 milliamps. Not sure what is the battery level, but let's wait because we reset the BIOS. Yeah, the laptop it is on. And we have picture. Yeah, time it's invalid, but that's fine. And the laptop is taking around 2.2 amps, 2.6 actually. Yeah, I'm gonna shut down the laptop to see exactly the charging current. Yeah. Okay, the laptop is going off. I think the battery is nearly charged. That's what I think. The battery voltage is 12.5. Yeah. Basically, the max voltage is like 12.8. It's taking only 600 milliamps, but it is working fine. It's charging fine. And here, yeah, same. Is this a proper repair? I'm pretty sure I will make happy some people. On the chat, I seen them. I'm happy for that, and I'm happy I helped the customer. I'm gonna stop here. I will say thank you for watching. And if you want to send me a job and you don't want to make me feel bad, just send me a spare board. Yeah, and I will understand. Yeah, like, subscribe. See you on the next one. Bye. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members only cool collection, and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.